In this lesson I'm going to talk about three-dimensional figures, as you can see. And the first three-dimensional figure that we're going to talk about is the polyhedron. Now a polyhedron is a solid, in other words it's a three-dimensional figure, where all of the faces are going to be flat surfaces, and they enclose a single region. So when you look at this one, it looks like we have a rectangle here and it's probably a rectangle there. All of those are referred to as the faces, and the pentagon that's up, what appears to be up front, that's referred to as a face as well because it's a flat surface. Now all the segments that are making those flat surfaces are referred to as the edges. And then where all the edges come together or they intersect, that's where you get a one vertex, or when we look at it plural, this point, this point, this point, those are referred to as vertices. Now I'm going to look down, I'm going to look at different groups of polyhedron. The first one's going to be the prism. And the prism is a polyhedron where it has bases, and those bases are faces that are parallel and they're congruent. And so as you see, two parallel congruent faces. I'm going to look at this one right here. So I look here and I see a triangle, and then there's a triangle back here. Those are congruent and they're parallel, so then it's referred to as a triangular prism. And those parallel congruent triangles are the bases of this triangle, or of this prism. Now notice the base is a triangle and it's called a triangular prism. In my next one, the base of this one's a rectangle and it's called a rectangular prism. This one, it's kind of hard to tell which one would actually be the bases, and it really doesn't matter. I could look at what looks like the right and the left, those could be the bases because they're parallel congruent rectangles. It could be the top and the bottom because those are parallel congruent rectangles, or it could be the back and the front as the bases because those are parallel and congruent as well. And then in the last example that I have, it's not the last prism, but it's just the last example I have, notice the bases of this one are pentagons, hence the name pentagonal prism. And what I do when I'm trying to figure out what the bases are, I look at my figure, and for the most part I ignore all the what look like rectangles. In many cases they will be rectangles, but they could also be parallelograms. Ignore those and find the other two faces. So here it's the triangles, those are the other two. In the pentagonal prism, it's the pentagons, those are the other two faces. So those are telling you the bases. Now in the rectangular prism, that's the one that's a little different because it really doesn't matter which faces you pick as long as they're opposite of each other, because then they're going to be parallel and congruent. But in all the other prisms, ignore the parallelograms or the rectangles and look at the two other faces, and those will tell you the bases, which will tell you the name of the prism. My next group of polyhedron will be the pyramids. And in a pyramid, all of the faces are going to intersect at one vertex except one of them. So in this one, I look down here, and in most cases people look at they think of it as the bottom to be the base, but it doesn't have to be the bottom. And that one is going to be referred to as the base. Because I could take this and I could turn it. Now the top is the base. Doesn't matter where it's at. It doesn't always have to be on the bottom. And then being the base of the triangle, we call it a triangular pyramid. Here, well, it's on the bottom, but I'm going to turn it around just so that you don't think that it's always on the bottom. And then I have a rectangle, so the name of it's a rectangular pyramid. And on this one, the base, look down here, it has 1, 2, 3, 4, 5 sides. It's a pentagon, therefore the name of it is called a pentagonal pyramid. I could have a hexagonal pyramid, I could have a dodecagonal pyramid as well, just depends on what the base is. My next one would be the regular polyhedron, and I want you to think back to just straight up polygons. We first talked about polygons, and then we talked about regular polygons. Well, in a regular polygon, all the sides are congruent, and all the angles are congruent. This is similar to that, other than it's going to be three-dimensional, and this is going to be made up of faces that are regular polygons, and those regular polygons are also going to be congruent. And then there's a special set of those regular polyhedron called the Platonic solids, and they're named that because Plato was the one who discovered them. But all of these are convex, meaning it's not caved in anywhere. Everything's coming out. And the 5 are right here, and I want you to know their names. There's the tetrahedron. Tetra means 4, so it has 4 regular triangles or equilateral triangles as faces. The hexahedron, hex meaning 6, so it has 6 faces. They're all squares. A lot of you are looking at that and saying, well, that's a cube. And you're right, it is, but the Platonic solid name for it is hexahedron, and I want you to remember that name. Octahedron, octa meaning 8, so it has 8 equilateral triangles as faces. The dodecahedron, dodeca meaning 12, so it has 12, and notice they're pentagons as faces. And then the icosahedron, that has 20 equilateral triangles as faces. Now I have a, oh, not that slide there, sorry. I have a, this where you can actually see them moving, a web page here. And on this one, it starts here, I have the icosahedron. Notice it has 20 faces, it tells it to you right here, and that's what I said earlier. It also gives you how many edges it has and how many vertices it has. I'm more concerned that you remember that it has 20 faces and that those faces are all equilateral triangles. If I go back to the dodecahedron, again, remember that it has 12 faces and that they're pentagons. The octahedron, octa meaning 8, has 8 faces and they are equilateral triangles. The hexahedron, sometimes referred to as the cube, has squares, and the tetrahedron has 4 triangular faces. So if you think about this, 3 of them all have equilateral triangles. The tetrahedron, the octahedron, and the icosahedron all have equilateral faces, and then there's the 2 that are different. The hexahedron has squares, or regular quadrilaterals, and the dodecahedron has the regular pentagons. Now, these are not polyhedron because they don't have flat faces. So these are classified at totally different. But your cylinder, it's kind of like a prism because it has these 2 faces that are circles that are parallel and congruent. And then you just have a big rectangle that wraps around it. Cone, kind of like a pyramid, but again doesn't have flat faces. But you do have this circle, and then kind of the sides, if you want to think of it. They're not sides, but they all go back to, it goes back to one point. And this is just one big figure here, and we'll look at what that looks like when you would unfold it. And then the sphere, well, I think of it, it's just a ball. And by definition, it's all the points now in space that are equidistant from one point. If you took away space here and put plane, then you'd have a circle. Set of points in a plane equidistant from one point is a circle, but when you put it into space, now you get the ball or you get the sphere. And the last thing we're going to look at is referred to as a cross-section. That's the 2-dimensional shape that is created when a 3D shape is cut by a plane. In other words, if I take my 3-dimensional figure and I cut it and then open it up, what's the 2-dimensional shape that I see? So I have 3 examples here of cylinders looking like logs here. So if I took my chainsaw and I cut through it this way so that it would be parallel to my 2 bases, I'm going to get a circle. Right here, this would be a circle. Now, if I took my plane and I cut through diagonally, what do I get here? Now that is going to turn into be an ellipse. You're going to want to write those down. And I probably should, and I'll tell you what, I'll type them in right here. This one, like we said, is going to end up being a circle. My next one, I said when you cut it diagonally like this, that's when you get the ellipse. Some of you would look at that and say oval, which, true, it is. The mathematical term for that would be ellipse. And then in my last one, if I took this and I cut it perpendicular to the 2 bases, notice I'm going to get a rectangle out of this cylinder. Oops, forgot the G in there. And it depends on what kind of figure you have. So if I were to take, say, a rectangular prism and cut them using these same kind of cutting methods, I'm not going to get a circle, I'm going to get a different figure. And similarly, if I were to cut a cone, I would get different figures as well. And it's something that you're just going to have to look at. And if you can't figure out what that 2-dimensional shape is or the cross-section is, please ask and I can help you out with that. And that's going to conclude my lesson on the 3-dimensional figures to start Chapter 12.